intro to stats is. And it's Math 146, as you know. It's basically to give you an idea of what statistics is. It's not going into any great depth, but it does go into a fair amount. I hope by the time that you finish this course that you'll be able to look at information that is given to you, numerical information that's given to you, and to look at it and understand how to make sense of it, and how to be aware when people are trying to confuse, lie, or emphasize something that may not be valid. Today's world, we are full of, we're being inundated with allegedly valid information that's tied together in a statistical way that makes it sound like it's telling you the truth. And I hope when you finish this class, you'll be able to look at it and say to yourself, I need more information before I can make a valid conclusion about what this information is telling me. So I'm going to give you a pretend story to give you an idea of how that might work. A newspaper article comes out, pretend one, and it says, Seattle police force is racist. Only 2% of Seattle's police force are Scottish. And that was their evidence. What other information do I really need to know before I can really make a decision based on the fact that 2% of Seattle's police force are Scottish? And that therefore means that they're racist. They don't like Scottish people. They don't want them in their police force. I need something else. What would I need to be able to make a better conclusion? What other information?
Number of Scottish people in the area?
Yeah. What percentage of Seattle are Scottish? Do you know if 2% of Seattle is Scottish, isn't 2% in the police force exactly what you'd expect in a normal, fair hiring policy, right? 2% are Scottish, 2% in Seattle. Perfect match. Suppose 10% of Seattle was Scottish, but only 2% in the police force. Wouldn't that be evidence that there is definitely an under-hiring of Scottish? Do you see how that extra piece of information makes a difference? Could go the other way. Suppose only 1% of Scottish people live in Seattle, right? 1% of Seattle are Scottish, but 2% of the police force is Scottish. Isn't that actually an overabundance of Scottish people? So you see how that 2% could be exactly what you expect. It could be evidence of racism. It could be evidence that they're getting more in their job. Isn't there, Boston's got far more Irish policemen than percentage of Bostonians, you know, something like that. So when someone hits you with a number and says, see, that is evidence to prove something, you've got to be able to look at that and I say, is that evidence to prove anything? And if it's not, what other evidence, what other information do I need before I can start putting that together? And a lot of politicians will hit you with information that is true. 2% of Seattle police force are Scottish, that's true, but the conclusion is not true. You know that's what their job is, isn't it? That's kind of how they do their bread and butter. Here's another one, made up one. In a small town, the unemployment rate has doubled. We should get rid of the mayor. He's doing a terrible job. The unemployment rate, right? The number of people who are unemployed, I should phrase it that way. The number of people who are unemployed have doubled in the last year. Guy's doing a terrible job. What missing information?
How many people are in the town?
True. How many people
have been in office?
Right. Well, how about how many people in the town? Let's phrase it slightly different, but that's essentially the same piece of information. Suppose there's only 4 people in the town unemployed, and now there's 8, but the town has a population of 10,000. Do you really think 4 up to 8 is that big a deal?
No.
No. The number of COVID death cases have trebled in North Dakota in the last month. Well, instead of 2 dying, 6 have now died. But can you see the headline? It sounds much better when you say it that way. Percentages can lie to you or give you a false impression. Do you see what I'm getting at? One piece of information, ask yourself, what else do I need to know before I'm sure? Right, so things that are 2% of this or treble that or doubling this, those kind of things are really dangerous information, because if I don't know the base value, where it's coming from, or a comparison value, I can't really make a valid conclusion based on that. So in the coming months, when you see information being told to you, maybe you can look at it and think, I wonder if that conclusion is really valid or not. Oh, and just because I don't like politicians, do you know most politicians know exactly what the truth is, but that doesn't stop them from lying to you. They know it was 2 and it went up to 6, but they know saying that's not going to get the oomph and the bang that they were trying to get, right? So they will phrase it in a way that makes it a lot worse sounding. And of course, occasionally they tell the truth as well, and you have to be aware of that. So let's get started while I'm getting myself organised and my usual bouncing around, because that's what I do. Yeah, you should all be looking at my whiteboard, I guess I'll call it. Introit stats. Well, let's start with the definition. Statistics essentially deals with information. Which is normally given in numerical form. Not always, but normally. So statistics deals with information. Information is very often called data. So we deal with data, which is normally given in numerical form. And what does statistics do? Well, it starts off at the beginning with how to collect the data. Second step is, well, if you've collected, how do you summarize it? Summarizing involves sometimes drawing pictures or using pictures to show you what the data looks like. Sometimes it involves using what are called statistics. Statistics, where the name statistics come from, you probably have met some of these. Have you met a guy called mean? Have you seen that somewhere? I'm pretty sure you have. You'd probably call it average, but its real name is mean. You know, like, I've got 3 tests, what's my average score? That kind of summary. What's the average age of OC students, right? We'd probably use a statistic called the mean to represent that. There are other ones. Has anybody, this is less obvious, but it depends on what classes you've taken. Have you ever heard the term median? It's another number, another statistic that summarizes some data. Anybody heard of median? Can you remember what it was? What's the median? If I said the median age of this class was 27, just a number off the top of my head, what would I be telling you roughly?
The middle number.
Middle number. The typical person in the middle, that would be the median. Then you get those things. And there's other ones that you probably may have met, probably in things like maybe chemistry. You ever did chemistry experiments where you got the standard deviation in the mean? You recollect doing maybe that in the physics or some kind of experiment? That's another measurement, but that measures how spread out the data is. So how you collect the data, then we summarize it. And thirdly, we then try and estimate population parameters. So estimating population parameters. A population is like everybody. Give an example how that would work. I'd like to know the average age of OC students, right? Every OC student that goes to a class this quarter, I'd like to know their average age. I guess I could just find everybody and ask them. But if I did that, wouldn't it take a lot of time and a lot of money and whatever? Couldn't I just randomly pick a couple of hundred of you and get their answer, right? So a parameter is the population number, right? The population age, the OC student age. And we would use it to estimate maybe, say the age. And we do that by using what we call a sample. That's pretty big. That's done a lot. Advertisers do it, the government do this a lot, where you don't ask everybody. You ask a small group of people, but you use that as a fair representation of what you believe everyone is. So, well, we're into the politics world now. Aren't there going to be what they call polls? And they'll go and ask, say, 1,000 people who you're going to vote for. And they come up every day or two and they say, the latest poll says that Biden's 47% and Trump is 44% or something, right? Those kind of data. That is an example of a parameter. And then fourth one is evidence to prove something. And this pretty much will be chapter, in our case, will be chapters 8 and 9. What does that involve? It's a fancy thing. You'll get into the details when we get nearer the time. And they're called hypothesis tests. What you do is you say to yourself, I wonder if there's evidence to prove that this new drug is better than the old drug. Right, that would be a medical example of that. Well, what you might do here is you'd set up an experiment where 500 people get the new drug and 500 people get the old drug, and then you see which group does better. And then you have to have some statistical work done on that, some number crunching, that proves without, with a certain degree of certainty that one drug has definitely done better than the other. Right now, that is happening in stage 3 trials for the COVID vaccine, right? I think depends on who you listen to and what papers and whatever you read. There's about 3 of them that are well into their stage 3, which is essentially the last stage. The stages that come before that are normally not to tell whether the vaccine does a good job or not. They're mostly there to, is it dangerous, right? They test it for side effects, because you don't want to give somebody a vaccine if, they die of a heart attack, right? They cured the COVID, but they got, some horrible other disease that killed them, right? So you do that. And we will be looking at how that is actually set up. And at the end, you should be able to, in many situations, say that you've collected enough evidence that you could take it to a court of law and win your case. So that's the big picture. That's what statistics is, the kind of things we're going to do. And we're going to look at, and today's a kind of big picture thing. So I know I'll be talking a lot and not doing too much specifics yet, but let's get the big picture thing done first, and then we'll home in on all the good stuff after that. So let's look at how to collect data. Seems like a pretty straightforward thing. Right. I want to find out some information. I want to find out what's your favourite colour. Right. I want to find out how old you are. I want to find out who you're going to vote for in the next general election. I want to find out what your opinion of abortion is. Whatever it is, right? There's a question that you're trying to collect some data on. And so you have to look at how you collect that data. And in kind of before that even happens, you have to look at what kind of numbers do you get? And you might think, hey, a number's a number, or data is data, but it isn't really. They're different kinds of data. See, if I went and said to you, what's your favorite color? Can you imagine that my data would come back as a list of colors? There isn't a number in sight there, right? Suppose I asked you how many children are in your family. Well, I don't have any children, right? There's one child in my family, right? I have a girl. There's 3 children in my family, right? I don't have any. There's 1. There's 7. There's 9. There's 2. Now, in that second question, the data I'm collecting is number of children. If somebody says, I've got 1.2 children in my family, are you going to look at them puzzled and say you're lying? Because I would. Would you agree that number of children has to be whole numbers, 1, 2, 0? If somebody said I had -3 children, I'd be a bit confused. So do you see that the data here is a number, but isn't it a particular kind of number? It's an integer, or a whole number in this case. And then I might ask you your height. Well, let's just make it in inches. I could be 65 inches. I could be 49 inches. Could somebody say, yeah, they could. Could somebody say I'm 39.5 inches? Would that be an acceptable answer that you could hear from someone? Is it okay to have decimals for your height?
Yes.
Yeah. Do you see that this set of data here could be any decimal, couldn't it? Theoretically. I know you wouldn't get anybody to say I'm 59.123 unless they're anal retentive, right? But theoretically, at least, isn't this data a different kind of number from that data? And when you look at what data is, then it has an implication on how you summarize it. I could certainly tell you the average number of children in a family. I think in America, for instance, it's 2.6 children, for example, right? Now, that doesn't mean that there are 2.6 children, because you can't get 0.6, but isn't that a number that says somewhere between 2 and 3 is a typical number of children, right? If I'm talking about the height of someone, if I was really accurate, couldn't I say the average height of an adult male in America is 64.123 or something, right? But could I tell you what the average color, favorite color? Do you see that makes no sense at all? Agreed? You can't say, well, 20 like red and 3 like green and whatever chartreuse is, somebody likes that color, right? You can't say an average color. Do you see then that the summary things don't make sense on certain data sets? Which is why we tend to almost always, except superficially, collect data that is not numbers. You can do a lot more when the data is numbers, can't you, than you can if it's what's the favorite country in the world you'd like to visit? You know, things that are things but not numbers, right? When you try and draw pictures of this data, it gets equally weird. For instance, if you were collecting data on colors, wouldn't your data look something like that? That's green, that's red, and that's blue. Do you see you would have little rectangles with gaps between them? And you'd probably have to do a diagram that looks like that, and that's called a bar chart. If, on the other hand, you were doing numbers of children, couldn't you do no children, 1 child, 2 children, 3 children. You see that the picture would look a little bit different. You see that there is an order to them and that the rectangles don't have a gap. So even visually, the graphs that you can draw are different. And back to the colour one. Couldn't I rearrange red, blue, green if I felt like it because I just wanted to? And wouldn't it make no difference to the table? It would still make sense. If you took this and jumbled it up, would you agree that it wouldn't make sense to do that? Doesn't it make perfect sense small to big? Because when the data is numbers, it has a natural order to it. When the data is not numbers, it doesn't. Well, that's just what the data is. That isn't even half the problem. How do you collect good data? I'm just giving the word good as a catch-all. To me, good data is true data, accurate data. We use a jargon word. We use the word unbiased data. Well, we know what bias is, isn't it? You know, politicians are biased, right, in favor of their thought processes, right? And somebody who was an unbiased commentator, wouldn't they be a person who doesn't care which political party? They just tell the truth as they see it. So, I mean, that might be an analogy of what unbiased looks like. So how do you collect unbiased data? Well, you must have, first thing is, you must have a representative sample of people. You ask the question to. So there's this question. Let's put a question. This one is a bit touchy, but I feel I still like the question, so I'm apologising beforehand. If I offend you, I am not trying to offend you. I am just trying to get a point across, right? So, if you wanted to do a fair representation of people, let's suppose your question was you were interested in people's opinion of abortion, whether they were for it or whether they were against it. Now, you could just get yes, I'm for it, or no, against it, but normally they don't do that. Normally you would do a scale that would look something like this. The typical scale is a 5-number scale. And on this side, you're very much in favour, and at this side, you're very much against. So on this side, people who find it very difficult to find a situation where they wouldn't allow the person to have an abortion. And on this side, you have people who find it very difficult to find a situation where they would be in favour of abortion. It doesn't mean a definite never or a definite it won't harm. I mean, at this side, they might say, yeah, I don't like abortion at all, but in case of incest or rape, I could see a reason where I might allow it. I might feel I can understand why it would be done. And this side, they might say, it's women's right, she should choose to abort. I have no problems with that. The only time I might be a little bit unhappy about it would be if it was a really late term abortion, where the thing that came out, no matter what word you use, you're already putting bias on it, right? That does it come out as a child or does it come out as a fetus, whatever you want to call it, right? But if it's livable, if it can sustain life, then that's the point where I say abortion's out. And then you have the kind of so-so crowd, right? I'm not really in favour of it, I'm not really against it, I really don't have a strong opinion. And then this is kind of, yeah, I'm in favour of abortion, but there's lots of cases I wouldn't, and so on. So this is your scale. So what would a fair representation of people be like? Well, it depends on the big question. Suppose I was in favor of American adults' opinion, right? And I go and I ask a fair representation. Well, a fair representation would have to be a fairly big number. Would you agree it wouldn't be a good idea just to ask 10 Americans and expect that that would give me a fair representation of the American population, right? 10 people is far too small, right? So maybe I should ask 1,000, right? So make the number big. That would be one fair representation. Do you think I should pick people in America who only live in Texas?
No.
Or only live in New York? Because isn't America not homogeneous? Don't some parts of America are more liberal and conservative than other parts of America? And can you see then, if I was doing a fair representation, shouldn't I do 1,000 people, and that 1,000 should include New Yorkers and Texans and Alaskans and every other state, right? And shouldn't it also include them roughly in the proportion that they are of Americans, right? So if 7% of Americans are Californian, shouldn't about 7% of my sample be Californians, I ask? Do you see how even a simple thing like the sample can be quite complicated to get a fair representation? Now, a lot of this stuff we will go into in even more detail, but this gives you the picture. So you can, somehow or other, I've figured out a good fair representation. I've got my little scale. Most people find that a very useful way. And you just see what your number is. I'm a 3, I'm a 2, I'm a 4, or a 5. The reason I can do that is that it turns the data into numbers and I can deal with numbers better, right? There's still one big major problem and a couple of minor ones. Here's the first one. It's a really big major one. And this is the one where I'll offend you. The way you ask the question can very often influence the answer. I'm going to deliberately choose some really bad, biased ways of asking, are you in favor of abortion or against, whatever way you want to phrase it. The first one is, do you think it's a woman's right to choose, after consulting with her doctor, whether or not she should have an abortion or not? Are you in favor of that? That's one way of saying it. Are you in favor of a woman being able to kill her unborn child just because she wants to? Now, they're over the top, totally bad, and certainly depending on where in the spectrum you fit, you would probably be at least offended by one of those two descriptions. Agreed? If I gave either of those two descriptions in my survey to that 1,000 people, can you see that the answers I get back could be quite different? Because can you influence people by the way you ask the question? If I said to you, this is not going to offend anyone now, if I went and said to you, are you in favor of the government spending more money on the homeless in Seattle? Then you might say, yeah, they need it. If I said, are you in favor of being taxed more so that we can pay for more money being spent on the homeless in Seattle? Can you see that you might get a different response? If someone else is paying, or if you're paying, doesn't that tend to influence what you might say to such a question? Most people are in favor of things being done that are good. And most people don't like paying extra taxes to do anything. You see there's a contradiction in those two things, because you can't have both unless you have somehow figured out how to make money out of it. So that's a major issue. Some of the worst data collection has happened in the phrasing of the question. And it's not always an accident. Do you know, a lot of the time it is deliberate. They know, they won't do it as over the top the way I did it. That was just obviously bad. But you know you can do it subtly. Right, I'll try and be subtle here. capital punishment, right? People being killed, put to death for heinous criminal crimes, right? Capital punishment. If you said to people in Washington, are you in favor of capital punishment? That would be the unbiased way to phrase that question. If you said, are you in favor of the Washington state killing inmates who have been convicted of murder? Do you see the word killing has a connotation to it? And not necessarily a good connotation. Couldn't you say murder, execute, kill? Now, at the end of that sentence, isn't somebody dead? But isn't execute and murder, one implies that it's okay and legal, and the other implies it's not okay and it's illegal. But aren't they both saying somebody's going to die? So you see how power words can influence you. And people in advertising know this. They know how to put words in that make you more inclined to go the way they want you to go. And so you're under that. Be careful about how you ask your question. Keep it simple, keep it unbiased, keep it straightforward, right? If you're ever asked a question and there's a preamble before it, you're being nobbled. So if somebody says, 1,500 Americans are killed every day in the judicial system, are you in favor of capital punishment? Do you see that preamble is trying to put you against it? Right, the sentence at the beginning, that's what I mean. Right, moving on. What else can you screw up here? Well, let's suppose I got a good sample. I asked it in an unbiased way. How could I still end up in trouble? Most of the time you won't, but there are a couple of very special situations where you will. If the question that you're asking is very sensitive, you will find that sometimes people will lie. Suppose you're interested in husband's fidelity, right? And so you get 1,000 husbands, married men, and you ask them, how many times have you been unfaithful to your wife? Can you see that there's a very big temptation for the people who are being asked that question to lie? Another example, you go to high school and you say to high school students, in the last month, how many times have you smoked marijuana? Or how many times have you taken crack cocaine or whatever the drug you're interested in finding out about? Do you see there is a very big temptation for people to lie? But if you want to get the real data, how do you get around that problem? Because it is a problem, isn't it? If it's very sensitive information, the information that you know it's difficult for people to tell the truth, how do you still get that good data? Well, what you have to do if you realize that that is a problem is that you have to ask the question in a very specific way. And you do have a preamble. You will say in high school to students, look, we're going to give you this form. And you're going to go into this office on your own, so there's no peer group pressure, nobody's looking over your shoulder to see what you've written. And we'll give you the thing and you put in your answer. You don't put your name on it. You fold it up and you stick it in this box and you give it a good shake. Whatever it takes, you try and make them feel comfortable that the information they're given can never be traced back to them. And it's also a good idea for you to tell them why on earth you want to know it anyway. Right, we're looking into, the health of high school students, and we want to know what kind of drugs they're taking so that we want to, gear our medical system and our prevention systems to what the drug of choice is now. Because, every 10 years it changes, right? They used to take this and now they're taking that, and we want to be on top of it, right? We want to know, what the drug issues are. If it's the infidelity one, you go through the same process. Look, we don't know your name. We don't care who your name is. Once we get that data, it just gets put in a pile with all the others, and that's the end of the story. And so if you can convince them that the information is safe and there's a good reason for why you're using it, you will get better data. So can you see this collecting data is not as easy as you might have thought it was? Isn't it fraught with all sorts of problems? And I think it's time for us to have a joke, because we need a joke. I do. Are you ready? Ripken, I better give you a joke. You poor guy. Okay, so Scotsman, Englishman, and an American die and they go to heaven. And they're looking around heaven with St. Peter and he's showing them the whole place and it's great, they love it. And the Scots guy's getting more and more excited the more he sees, and he gets to the point where he can hardly control himself. And he says to St. Peter, he says, heaven is really, really, really big. He says, how do we get around? Do we get cars? And St. Peter says, yes. And the Scotsman gets even more excited and says, does that mean we get any car we like? Can I get any car I like? And he says, well, no, it doesn't quite work that way. What we do is we ask a question and we already know the answer, but depends on the answer. That'll decide what kind of car you get. So it goes, we'll do it right now. So St. Peter says to Scotsman, how many times have you been unfaithful to your wife? And the Scotsman says, I've never been unfaithful to my wife. And he looks at his little note and says, yep, we got it here. You're telling the truth. Scotsman says, what kind of car did I get? And says, oh, you're getting an open top fancy sports car. And boom, it appears. And he jumps in and zooms off, dead happy. And they go to the Englishman and say, well, what about you? And the Englishman's kind of shy. And he says, look, we already know it. You just tell us. How many times were you unfaithful? And he says, once. But she forgave me just once and that was it. Never done it again. And he looks and says, that's right. He says, so Englishman kind of says, well, what kind of car am I going to get? He says, well, you're not going to get the Scots guy's car, obviously, but we'll give you a good car. So he gets a nice, 5-year-old Ford, and he gets in and drives away. And they go to the American, and he knows the question's coming, and he says, I don't want to tell you. So look, we already know, you've just got to answer it. How many times? He says, 27. And he looks and says, 27? He says, you're lucky you got in. He says, I don't know how I armed. I'm glad I get in. He says, so what kind of car are you going to give me? He says, well, you get nothing like the rest. So this guy's 6'6", and they bring him this tiny little Mini where the door doesn't, it's hanging off and the windscreen's cracked and the seats don't work, and he's scrunched in and he's driving away. And the next day, the three of them meet up at the traffic lights. And the Scotsman's in the middle, and the American on one side, and the Englishman on the other. And the two of them look in, and the poor Scottish guy's crying. And the American looks at him and says, why are you crying? Look at the car you've got. Look what I'm driving. Why are you crying? And the Scots guy says, oh, I just saw my wife and she's using a roller skate. I'm waiting for that one to sink in. I don't know. I think I've killed Ripken. Well, that was good. I've never done that to a student before. I'm feeling kind of proud of myself. That's one of my favourite jokes, by the way. So, are you okay with that joke? I didn't offend anyone, I think. Right, good. Oh, Joshua just got that joke. Okay. Sometimes it takes a while to sink in. Okay. So what we're going to do now is kind of start, if you can bear with me, some of the jargon terms. I know statistics, because it's its own subject, has to have a lot of words. So I think the best thing I can do right now is spend a little bit more time, maybe, 15 minutes on just some of the jargon terms, and then I'll go to WebAssign and we'll show you a little bit about that and show you what your homework looks like, in case you're wondering, how things, how does what I've just done how can you do homework on it? You know, what does homework question even look like? So let's start with, oops, I'm in the wrong picture again. I just wanted to see the reactions on my joke there. I should be able to do it. Here we go. Right. Okay. So here's our first term, and what does it mean? When you say the word population and statistics, you're talking about all the people of interest. In your question. Give you an example. Suppose I wanted to know the average age of Americans. My population would be everybody in America. Would you agree it wouldn't be much point in finding some French visitors and asking them their age? Right? I don't want to know what their age. Population in that case would be all Americans. On the other hand, suppose I was only interested in the average height or the height of high school students in America, right? High school students in America. Would you agree it wouldn't be a good idea for me to go to kindergarten and measure any of those? And it wouldn't be any good going to France and looking at their high school students. Do you see the population is only those people that are important for your question? If I wanted to know who you're going to vote for, which I will never ask you, it's none of my business. But if I wanted to know who you were going to vote for, right? It would only be American people that we would be interested in, right? And in fact, it's not just American people or even people who live in America. Do you know it's only people in America who are allowed to vote? I am not allowed to vote in America. I am not an American citizen. I'm a permanent resident, so I don't vote. So it's not my fault. But you lot, or at least those who are the correct age, yous are. So I have been at the receiving end of pollsters asking me things like, who are you going to vote for? You ever had the phone thing where they phone up and ask you who you're going to vote for or whatever it is? I say, I can't help you, I'm not allowed to vote. And normally they're pretty good at that. Another thing, do you know when you do initiatives and you have to sign initiatives? Things like that? You ever been outside Walmart and they want an initiative for whatever it is, Initiative 42? I'm not allowed legally to sign any of those things because initiatives must only be done by people who are legal and vote in America. Although I'm legal, I'm not allowed to vote. So that's what a population looks like. So we have another guy called a sample. I've used this guy before. A sample is a small group of people from the population. So I might ask 1,000 voters, who are you going to vote for? I may ask, I may find the height of 200 high school students to get their height. Those 200 or 1,000, that's a sample, right? Now, if you want a really good sample, shouldn't a good sample be a fair representation of the population, right? As we talked earlier. Yeah. These two sound like the same thing, and most of the time they are. Your sample and your sampling frame should be essentially connected. The sampling frame is basically, should be the same thing as your population. So when you get a sample from a sampling frame, It should be the same thing as getting a sample from the population. Unfortunately, it isn't always the case. I'll give you an example. Suppose I was interested in how you're going to vote in the next election, and I choose randomly 1,000 people in America to phone. My sampling frame there would be people who I could phone, right? People who have a phone number in America, right? That would be the sampling frame, right? That's the people I'm picking from. Are the people who've got phones the same thing as all the people in America who can vote? No, aren't there some Americans who just don't have phones? So they can still vote, but they don't have a phone. I'll never ask them. Some people have ex-directory, so you don't even know their phone number, so you'll never be able to phone them. They won't be in my sampling frame either. Can you see that in that case, won't I not be you actually asking? My sample won't be from the population, right? My sampling frame will be from a subgroup of the population, people who have phones. Now, sometimes that doesn't matter. If I ask you what's your favourite colour, do you think people with phones or without phones probably differ that much? Probably not. But if I'm asking you who you're going to vote for, couldn't that be important? I'll make an assumption here that may or may not be true. Maybe people who don't have phones for the most part because they're poor. And maybe poor people tend to vote more one party than the other. Can you see how that would influence my result and underestimate the party that might be voted in that way? Can you see how that might have an effect? As you watch the TV, try and pay attention to this. When they talk about samples, they're really talking sampling frames, and they will mention it if they're being honest. And they mention it in different ways. Sometimes they do registered voters. Sometimes they do, I think it's different phrasing, but likely voters is the most common phrase I've heard. Now, likely voters and registered voters are not the same thing. Right, registered voters are, you're on the voting list. You might turn up and vote, you might not. Registered voters are people who can vote. But aren't likely voters people who've said, I intend to vote this year? I'm not, I'll tell you later who, but I intend to vote. If I was doing a poll then, wouldn't you consider likely voters to be a better sampling frame than people who are registered to vote? Would that seem a reasonable assumption? And not all pollsters do likely voters. They also have a really sneaky one, which they will never tell you, but I know it happens. When you pick your sample of people you're going to ask, let's say it's 1,000 people, they should use what's called a simple random sample process, which means anybody in America has just as much chance as being picked as anybody else. But they don't. Most pollsters use it's almost like a self-fulfilling prophecy. I'll make an example up. Let's suppose in Washington state, 55% are Democrat and 45% are Republican, just for argument's sake, right? When they do a poll in Washington, do you know that they choose the poll as 55% Democrats and 45% Republicans, and then they ask them who they're going to vote for? Do not be surprised when the answer comes back that 55% are going to vote Democrat and 45% are going to vote Republican. Because if you ask people who vote a certain way, how are they going to vote? Do not be too surprised when they agree with what they said they were going to do the first time. Can you see that is a very weird polling system? Now, they may sneakily get it by you. They call it a weighted poll, right? W-E-I-G-H-T, a weighted poll. If you ever hear anything that uses a weighted poll, well, you just ignore it. Pay no attention to it. It is fraught with biasness. It just is. And that's my sixth sense for it, right? So the best voting system or the best sampling system is called a simple random sample. And that's what's going in here. Now this is a sample where every person in the population has the same chance of being chosen for the sample as anyone else. In statistics, a simple random sample, SRS, is considered the holy grail of sampling. You just figure some way, and it is extremely difficult to do. It's much more time consuming and certainly much more costly than many of the other systems that they use. But the simple random sample is always going to give you the most likely realistic result. Because anybody in the population, so right, it's not a sampling frame. You're not picking them according to who they voted last year. You're not picking them because they've got a phone. You're not picking them because they live in Kansas, right? You're not just choosing a small group to represent all America. Anybody who can vote in America could be picked, and anybody who could be picked just as likely as anybody else. Can you see how random that is? And that tends to generate really good results. Almost nobody in the political world does that. It's extremely expensive. Because you know, to be able to do that, don't you have to know where every single voter in America is? Because they might get picked and then you have to go and find them. So once you've picked them, John Smith from Bremerton, you then have to go and find John Smith from Bremerton and ask him who you're going to vote for. You see how expensive that process would be if you tried it 1,000 times. But it's the best one to do. Is there any questions before I move on and start showing you what this homework looks like? Because you've probably heard me talking long enough. Last chance? Okay. Let's cut this thing out. And let's go hunting for, where are you? Okay. I think I'm here. Here we are. Right, now. Here we go. I don't know, are you looking at WebAssign right now, or are you just looking at some screen? Can you see it? Okay. Now, the way this course is going to work is it's going to be in 2-week blocks. So this week and next week is our 2-week block. During that 2-week block, you have these 4 sections of homework to do. That one there hardly counts. It's about 30 minutes to do that, but these 3 will. And you're going to go through these questions. These are your homework assignments. Sunday on October the 4th, midnight, it has to be done. So don't wait till Saturday night and think you're going to do 2 weeks homework. It just won't work. This one here is pretty light compared to some of the ones that are going to come in the future, but that's fine. If you see it here, it means that if you can see it, it means it's to be done in the 2-week period. And then once that's finished, these homeworks will close and you can't do them anymore. And then on the following Monday, that'll be October the 5th, you'll get your first test, and your test will be in chapters 1 and 2. And then we have 2 more weeks work, got to get the homework done, then a test, 2 weeks work, test, all the way to the end. The last one technically is 3 weeks because Thanksgiving and the holidays are there. So it's like 2 weeks of schoolwork, but 3 physical weeks. So it still counts. And that will be the last one. And then you'll get a test. And then after that, you've got your final. So let's have a look at this fella called View. And I may have to go out and in. Are you seeing the homework? Can you see it? I see nods. And I see sheets. Okay, I'm going to go out and in just in case it's an update screen thing. Right, you should definitely be seeing the homework now. Good? Right, now let's kick out the key. You don't get that. If you've not done WebAssign, essentially you get questions, and in this case, a little bit different since it's sentences and so on, but we'll come to that. And one answer, or more than one sometimes, you just click on it and then you hit submit, and if it's right, great. If it's wrong, you get 3 shots. So it's 3 shots in it. 32 questions, pardon me. It's all on chapter 1, which is Introduction to Statistics. And there's a whole load of questions here. And they go on and they give you all sorts. I'm just scanning through this randomly. And they go on and in this, can you see that most of your questions involve you choosing something with the little dot? Right. So this section is not like your usual math class, where for the most part, you'd expect to solve equations or do calculations with numbers. But that's fine. That's what it looks like. So if you're wondering what your homework looks like, this is essentially what we have. It's basic. I'll pick one at random. There we go. Which one? Right. Even although we don't know this yet, because we will cover it, this is an example, question 10. Categorize these measurements, which I would call data, associated with a robotics company according to the level nominal, ordinal, interval, or ratio. Right. So these are the jargon words for the kind of data that we talked about. Nominal data is data like red, blue, green, and yellow, right? There's no numerical value associated to it that you could categorize, right? You can't put a number to it. If you look at the other kind of numbers, ratio and interval and such like, these are different types of numbers. For instance, ratio numbers would be numbers where if you doubled it, it would make sense. So if I went and said to you that one team scored 4 points and the other team scored 12 points, it would make sense to say that one of them was 3 times as big as the other. Right? That would be an example of a number that's a ratio number, right? So you can talk about percentages and ratios, and it makes sense in the context. That can catch you out sometimes. I'll give you an example. Is 60 degrees Fahrenheit twice as hot as 30 degrees Fahrenheit? Now, superficially, a lot of people say yes, and this is why it's subtle. The answer is no. Now you say, wait a minute, 60 is double 30. What are you talking about? 60 is twice as hot as 30. No, it's not. Suppose you could turn 60 degrees Fahrenheit into centigrade. Would those numbers be double now? No. Do you see that those numbers had a unit that was quite arbitrary? Isn't degrees Fahrenheit, degrees centigrade just an arbitrary measurement unit? So it doesn't make sense, even although people will say it, to say it's twice as hot as it was last week. They can say it's 30 degrees hotter, and that's allowed, because that would be true, but you can't say double, so it wouldn't count as a ratio. Say a little sneaky one. Try a different one. Is 4 inches, this will get you worried now, is 4 inches twice as long as 2 inches? Now you're not wanting to nod anymore. Is 4 inches twice as long as 2 inches?
Yes.
Good, man, yes. But what about if you change the units? Fair enough. Couldn't you change 4 inches into centimetres and 2 inches into centimetres? You know, you just multiply it by 2.54. If you did that, wouldn't it still be double the other one, but now in centimetres? So do you see how that unit of measurement, length for instance, is a ratio? Height is a ratio. Measure somebody in inches, measure somebody in centimetres, it won't matter, right? They're still twice as tall as the other guy. I'm still twice as heavy as the other guy, right? But I'm not twice as hot as the other guy. So each one has to be taken on its own merits. Why is that important? Well, it's almost lawyer-esque. It probably won't kill you if you say something's twice as hot, right? It might not be perfectly correct to say it, but it's not a biggie. But we go into that. So a salesperson's performance, you either tell them they're average, below average, average, or above average. Can you see that that's really just words? It's like red, blue, green. But it does have an order to it, doesn't it? In the sense that I think below average is not as good as above average. So in that case, we would use the term ordinal. Ordinal just means that it's still not numbers, but there is an order, a natural order that most people would agree to. How about the price of a company's stock? Right, it's $200 a share or $50 a share. Now, if you're not ratio, you're probably interval, right? Just think of it like that. Would it make sense that the stock doubled in the last 2 years?
Yes.
$200 is twice as much as 100. Agreed? Would it matter if I turned it into francs? Would it still be double the price? Yeah. What about gross income? How much money you make in a year? Would that be ratio or interval?
Interval.
Interval. Suppose I turned what I made into pennies. Instead of telling you in dollars, I told you how many pennies. Wouldn't it still be twice as much money? If I converted it into pounds, it would still be twice as much money, right? The colour of the packaging, right? Red, green, yellow. Wouldn't that be the worst data level, nominal? Does red come before blue, comes before green? Is there any natural order to colours, really? Not in my brain. Right? So nominal is the lowest level of information. It's a thing, you can count it, and that's about the end of it. Ordinal's a little bit better, but it tends to be things that have an order to them, but the data itself may well not be numbers. So do you know that Likert scale I gave you, the 1 to 5? You know, 1 against abortion, 5. That would count as an ordinal data. The 1 to 5 would just make it easier for people to count them, but it really transfers, isn't it, into I'm definitely against abortion or whatever. But it does have a natural order to it as well, doesn't it? So it's ordinal. If it's got an order, ordinal. If it's not that much good, it's nominal, right? So if you're trying to get your brain out around the nomenclature. If you can double it and it makes sense, it's a ratio. And if it's a number, but doubling it doesn't make sense, call it an interval, right? Let's throw in some scary ones. Shoe size. You collect data on shoe sizes, right? You agree it's a number. If you have a shoe size of 8 and a shoe size of 4, is your feet twice as big as the other guy's feet? No, that's not how shoe sizes work, is it? I don't know how they work, but they don't work that way. Agreed? So we just call that a number. The numbers on American football players' jerseys. Yeah, number 42, number 67. You know those guys? Is number 42 twice as good, big, heavy, paid as much as number 21? You see, it is a number, but is it really a number that has any great significance? In fact, in that case, you could argue that it's ordinal. Although it physically is a number, isn't it really just a code? I don't know of any American sports, but I do know some British sports. Do you know in some British sports, your jersey doesn't have a number, but it has a letter in a number? Like you're a R2 or a left 3. Ripken, you're nodding like you've seen that somewhere. Do you know what I'm talking about? Right. So in that case, wouldn't it just be a code, in which case it might be ordinal? I guess you could put them in order of, you know, the smallest number to the biggest number. So can you see that your homework is going to be, now, please don't do this. Because you get 3 guesses and there is very often only 3 or 4 shots, couldn't you simply just randomly guess it's wrong, randomly guess it's wrong, and then pick, and hopefully you got lucky on the 3rd one? Right? It wouldn't be a very good method. Just to show you very quickly, because it's easy for me. If I click on this, okay, boom. Since this is the last part, I want to do this and I want to have a look at Canvas. Question 1, in a friendly study, can you have an unfriendly study? Right, in a friendly study, what is the difference between an individual and a variable? An individual is a member of the population of interest, and a variable is an aspect of an individual subject or object being measured. Okay, so an individual is the person that you ask, and the variable is what you asked them. So if I said, I'm picking George and it's his height, George is the individual, but his height is the variable. So when you collect data, the 1,000 people you ask are the individuals. And the variable is typically one thing that you ask them, right? Who are you going to vote for? What's your age? So some of these questions, you have to be careful. They will tell you more than one answer may apply. Now, in this question, it's 1, in this question, it's 1. But can you get some questions where there might be 2 answers that are allowed? So it's not very intelligent, this thing. So see if you get 1 right, and it should be 2, it will just tell you that you're wrong. And so you'll think that the 1 right is what was the problem. The problem was you didn't give the second one that was also right. Right, so you have to read the question carefully, because I've seen people get caught out in that. There aren't any number stuff worth talking about in chapter 1, but in chapters 2 onwards, you're going to deal a lot with numbers, and you have to be extra careful because the software is unforgiving. If it says to 1 decimal place, you have to type in 2.1. Don't type in 2.12, which is the correct answer to 2 decimal places, because it'll say you're wrong. And be careful when you round off not to round off the wrong way, in which case you'll get it wrong. So you can do really horrible 10-minute questions, and the answer's 2.12, and you type in 2.1, and you scratch your head and think, I'm getting this wrong, and all you did was a rounding off issue. So be aware of that. And for the last part of today, which is a good place to finish, let's go in and get myself set up for Canvas. Does everybody here, have you been, and if you've not, will you please go in as soon as you can to our site, our Canvas site? You're not allowed to look at it yet. I'm taking you to it right now, in case you haven't, and even if you have. Okay, out and in.